The last thing we're going to talk about today is the average cost. We know how to find average. Anytime we want to find average, we sum all the values and we divide by the total number of values. Well, that's great, except if we're using integration, there's infinitely many values that we need to add up. For example, if we want to find the average temperature over a day's time, there are too many possible temperatures to add them up. This is a job for the definite integral. With the definite integral, I can add up all my values. I can say, let me measure this height, and then let me measure this height, and let me measure this height, and let me measure this height, and so on until we get done. And then we count up all of our values and we divide by that. But it's actually impossible to do since there's infinitely many of them. The average value of a positive f has a nice geometric interpretation. Imagine that the area under the curve in figure A is a liquid that can leak through the graph and just settle. Notice in B, that's what's happening. Anything above this line that they're calling H has settled down to even out, and it evens out at H, which is the average height. So if the height of the rectangle is H and the area of the rectangle is H times B minus A, which is the width, then we know the area is the same as the area under the curve. We can say the area is the sum of all the values under the curve, and we're going to divide by B minus A, the width of the interval. And that's how we get this formula. The average value of a function over an interval between A and B is this right here is the total number of values. And this here would be the area under the curve, or the sum of all those rectangles. So we want to find the average value of the function f of x equals 6x to the fourth on this interval. Well, this is A and this is B. So I would have the integral from 2 to 4 of 6x to the fourth dx. And out here, I would have 1 over b minus a, which is 4 minus 2, or 2. And this would give me my average value. Let's compute it, see what we get. This is equal to 1/2 times the integral of 6x to the fourth. We'll take the 6 out. We'll take the integral from 2 to 4 of x to the fourth dx. We have 3, 6 divided by 2. Then we have the integral of x to the fourth, which is x to the fifth over 5. And I want to evaluate that between 2 and 4. This is 3/5 times 4 to the fifth, 2 to the fifth. And I can do that because I really have this constant 3/5 here. I can just pull it out and then just evaluate x to the fifth between 4 and 2. This is equal to 3/5 times 1024 minus 32, which equals 3/5 times 992, which is equal to 595.2. And that would be the average value of the function on this interval. All right, now we have our last example. Suppose you deposit $6,000, 4% interest, compounded continuously, and we want to find the average value over the first 2 years. First thing we have to do is remember that we have a formula for this, which is A, our accumulated value, is equal to E to the RT, sometimes known as PERT, where P is equal to 6,000, R is equal to 0.04, T is equal to 0 to 2. Our formula says that the average is equal to 1 over B minus A times the integral from A to B of our function. 1 over 2 minus 0 times the integral from 0 to 2 of P, which is 6,000, E to the 0.04 T power dt. And we do not have a formula for this, so let's simplify it as much as we can and see what to do next. I'm going to take the 6,000 outside of the integral sign, 0 to 2 of e to the 0.04 t dt. I don't have a formula for the integral of e to the 0.04 t dt, but I can use substitution. U is equal to 0.04 t, du is equal to 0.04 dt, and if I want to solve for dt, I'm going to divide both sides by 0.04. I get du over 0.04. And then if I want to change my bound so I don't have to put it back into t form, when t equals 0, u equals 0. And when t equals 2, u is equal to 0.08. Now, this is equal to 3,000 times the integral from 0 to 0.08 of e to the u dt is equal to du over 0.04. I get 3,000. I'm going to take that 0.04 and put it on the outside of the integral, and then I just have e to the u du, and I know that's equal to e to the u. And I'm going to evaluate that between 0 and 0.08, and I don't have to change the u back to x's because everything is evaluated in terms of u now. This is now equal to 3,000 divided by 0.04, which is 75,000, times e to the 0.08 minus e to the 0, which is 1. And our final answer will be $6,246.53. That is my average value in my account over the first 2 years of me having that account. And that is all I have for now. Thanks for watching, and we have one more video to go. Bye-bye.